of the LRIs, and LRI stands for Lead Robot Inspectors, for the Arizona Regionals. So I've been doing this a very long time. This is this game year is going to be my 21st year volunteering at a regional. So yeah, I'm old. But I started out on team just like you guys. So I understand that when you're looking at what's going on and going through the process, you're thinking, these are the guys that are keeping me off the field. So a couple of things that I want you guys to know. The reason that we do inspections is because we want to keep the gameplay fair, but the number one reason is we want to keep everyone safe. We want to keep you guys as the competitors safe. We also want to keep our field staff safe and all of our spectators safe. So that's the reason that we do the inspection. The role of the inspector is to not stop you from getting on the field. Our goal is to get you on the field. We want you guys to make every single practice match that you have. We want you to make sure that you definitely don't miss a qualifying match because you don't get that many of them. So the inspectors are there to help you get through the inspection and get out there on the field. I'm going to go through a bunch of stuff that'll help you help them do that. But the other thing that I want to let you guys know is the LRI. What is the role of the LRI? As the lead robot inspector, we are there to help with everything that has to do with the inspection process. So if you're going through something and you're like, you know what, I think that rule is different than that inspector is saying it is, call me over. Please, please, please don't go through something thinking that something's wrong or having to make a big change when you feel that the rule is different. We'll take a look at the rule. We'll go through it. Please go up higher. Maybe, like that? Okay. And I'll help you try to get through that rule change. Also, make sure that when you're hearing from an inspector, or even from me as an LRI, that you fully understand what it is we're asking you to do. If we say, hey, you got a little bit of your bot sticking out a little bit, try to fix that. And I come back 10 minutes later and you are sawing your bot in half when all I needed you to do is bring back one of the brackets. Make sure that when you're done with inspection or you're going through to make those changes that have been asked of you, that you fully understand what it is. A lot of the inspectors will work really hard to reiterate all the things that they have gone over on there, but they're not there to tell you exactly how to do it. If you guys need that additional assistance, they're definitely a resource for you. But we try very hard to make it so that we're not telling you, do exactly this, because it's your robot, and you guys can come up with these ideas how to creatively get through it, and more than likely in a better method than you may have been told. So that's one thing to remember. But always remember that if you guys have any problems, whether it's something was called on the field that has to do with your robot, or it's something that's happening during inspection, or something's going wrong, feel free to come get me, or our other LRI this year is Damon, and he's been on my inspection team a long time as well. And so for one of the events, I'll be the LRI. For the other event, he's the LRI. And I get to actually inspect robots, which up until recently has not been a thing for many, many years. Never gotten through a full inspection as an LRI. I always get called away. All right, so important documents are the game manual and the inspection checklist. These are two documents that by understanding and reading these, you will fully understand what is expected at inspection. This one seems like a pretty big no-brainer. After kickoff, read the rules. But I know when you first see that document, you're saying, darn, this is a 130-page document. There's no way I'm going to get through this. No way I'm going to memorize. You don't have to. One of the things that I highly recommend is that you go through all of the rules as a team, but then you have a point of contact on your team that is somebody who, they are the rule guru, okay? They know that book backwards and forwards. They're also looking out for those weekly updates and keeping up with the Q&As. These Q&As kind of like case law, where it's not exactly what the rule said, but it has been defined by the game committee, and those can help you out. There's times that some of the questions are more vague than they intended them to be, and those clarifications can actually help you. One of the other things I suggest is that if you have leads for each one of your different builds, so if you have your coding lead, your mechanical lead, your pneumatics lead, electrical lead, those guys, have them know that section so that when they're going through with their team or you guys as a whole team and they see something that's not going to work, it's a lot easier for them to see that if they know that that rule exists. All right, before an event, one thing that you should really do is a pre-inspection. Now, there's a couple of ways you can do this. One of them is just as a team, go through, take that inspection checklist and start going through it. One of the nice things about the inspection checklist is it lists what rule it's referring to right behind it, so you can pull it up and look at it. You can also go to one of our pre-inspection events, which happened before the regionals here in Arizona. Last year we did 2, where we had inspectors at events like Duel in the Desert, and the other one was an event we had at Si Se Puede, where we have inspectors there with a scale to weigh your robot, to go through the inspection as far as you want to go through it. Your robot doesn't have to be perfect to go through this. All right, so things to get through quickly. If you want to get through inspection quickly, be ready to get to inspection when you arrive to the event. If inspection is open, if you're the first one up there, you're almost assured that you are going to get an inspector to go back to your pit with you to finish the inspection and get you out and ready for those practice matches. I get a lot of reasons. There's a lot of reasons here not to be ready. I just have one more thing to fix. I hear that one all the time. My code's not ready, or I left my programmer at home. My motors aren't working yet. My pneumatics need work. My dog ate my controller. These things have happened, and I understand. But one of the things that you might not realize is that almost every single one of these, and in this case every single one, you can get a partial inspection done. Then when you get that one thing you're working on fixed, you can then have a short list of things that have to be finished to get you out there. So instead of having 50 things to check off, now you only have 10 or something like that. So if you just have some small issues, especially my pneumatics aren't working, this is something that happens to teams all the time. We can get you on the field with your pneumatics not working. What we do is we basically disconnect the pneumatic system, which just means everything turns into basically robot weight or ballast, and we get you out there with all of that not working. Then when you're done with that match or practice match, you come in and we work on getting that pass-through inspection. That way you don't miss that match. You may not be able to run to your full potential, but you were there and you got that practice in. All right, at inspection. So one of the things that we need when you first get up there, if you want to get through quickly, is have your bumpers off, the batteries out of the bot, and ready to get weighed. You also will need to bring your bumpers, both colors, and all your mounting hardware for it. As it says, bring everything to inspection. And mostly that is, it means basically everything that's going to be on there. One of the rules that I don't see a lot of teams actually taking advantage of that's there, at least not here in Arizona, is the 150-pound limit for all mechanical. This means that you can actually have a defensive setup and an offensive setup and switch those mechanisms out as long as the combined weight of those mechanisms does not exceed 150, and that when that system is on your robot, your total robot weight does not exceed the 125 pounds. Now, one of my absolute favorite rules is I-107, no student, no inspection. Your mentors may know your robot, but I don't want to hear from them. I want to hear from students. The program's here to help you guys get to the point where you can not only build what you need to build, but you can communicate that build to someone else. Especially, these inspectors, you don't know them. They're not one of your mentors usually, and they won't be one of your mentors for your inspection. But they are there to, kind of like a review of something. You're able to present to them and answer questions for them. So if there's no students, we won't do the inspection. All right, the inspection. Now, when you look at the inspection checklist, you're like, that's a lot of stuff. And I'm going to have a hard time getting through all of that. So let's break it up a little bit. So like I said before, bring everything to inspection. If you have alternative mechanisms, bring that up with you. All right, so when you first come up to inspection, with your bumpers off, your battery out, we are going to do the total weight. If you have alternative mechanisms, we are going to weigh the robot with the bumpers off. We are going to weigh the bumpers, both colors individually. If they're split bumpers where your colors flip-flop, we'll weigh it one to that weight, and it's both. We're going to check the frame perimeter, the starting configuration, the starting volume, and the plane configuration. Some of these rules change year to year, so we'll see tomorrow, right? But those are the kind of things that we're going to check there. Then we're going to either have an inspector walk with you back to your pits, or we're going to put you on a queue, and as soon as the inspector's available, we'll send one to your pits. This is one of the reasons that if you're really wanting to get through fast, get there early, because I have a limited number of inspectors, and if I only have, let's say, 5 inspectors, and we have 60 teams, let's hope that doesn't happen, because it's very hard. I've had years like that. It will be a long process if everybody comes 30 minutes before the close of pits. So if you get in there fast, we can get that going. All right, back at your pits, things to know. We have to get to almost every side of your robot, so make sure that there's room in your pit for us to get around it. If you have 30 team members and they're all sitting in the pit, it's probably not going to happen. So you may want to send anybody that's not necessarily extra, but somebody that's not crucial to that inspection process, and have them wait outside the pit until it's done. One thing that we do need is if you have leads for each one of your teams, for your pneumatics, some teams have one person that knows the entire robot backwards and forth. But most teams have somebody who's in charge of electrical, someone in charge of pneumatics, and that. And so if that person's there to answer any of our questions, it makes it a lot easier than, I don't know, let me go up to the stands and find that person and bring them back to answer your question. Like I said, my favorite rule, no student, no inspection. I do want to hear these answers back from students, and you will be asked questions about each individual part of your robot. Don't let that get you anxious or anything like that, because we're not asking for this perfect answer that's been rehearsed or anything like that. These questions are just there to help us understand your bot and understand how it was assembled, to make sure that it's in compliance, and help us understand how you got to the process of something, even if it is something that needs work. That might make it a lot easier to figure out how to help you. All right, the dreaded section, the section that every year we have the most trouble with, but every year teams struggle with, bumpers. So, as you can see, this rule has the most sub-check boxes out of all of the rules, because bumpers are the thing that just every year it's really hard for teams to get it right. So, a couple of things to remember. These pictures are in the manual, so if you guys want to refer to any of them, they'll be in there every year because they want you not to struggle. Some of them are not the clearest. What that okay is pointing to is, I don't think, necessary to this, but some of the rules that are important, and again, some of these may change tomorrow, but most of these stay the same. We want 6 inches protecting every corner in both directions of that corner. The corners have to be fully filled, which we'll talk about a little bit more afterwards. You can't have a bumper that's less than that, even if the wall that's behind it or the area behind it is less than 6 inches. That won't work. So that's something where if your design has your opening over here and you're unable to put that bumper in, then that's a major change that you have to make when you're at the regional. So we don't want that. So make sure that you're looking at this ahead of time. A couple of things over here. If you have a design like this where you have a corner that is not, if you basically took a string and went from the side of your robot to the side of your robot and made this type of corner, that won't work because there's no way to protect that correctly. Because a bumper inside of a gap inside the perimeter is not a bumper. It's an additional item in your bot. Make sure that all the corners, even if they're not full corners, are covered by that when you go. This one we don't have as often, but things to remember. The wood cannot extend past, the backer of the plywood cannot extend past the backer of the other one by more than 1 inch. It's okay to have an open like that. It's okay to close it off. It's fancy if you do this. So it's up to you guys. But all right, building the bumper is pretty straightforward. There's not too many teams that don't understand this part of it. 2 pool noodles in there, a covering that is rugged. I recommend something that is not going to tear. I've seen some fancy, almost silk-looking covers, but they don't hold up very well. So something rugged that's going to take that abuse from other things. If you look at this stuff, it's like almost a canvas-like material. It's a synthetic cover, but that's a nice rugged material. But one of the things I really want to talk about is fasteners. Fastening your robot bumpers to your robot is one of the things that teams struggle with. So one of the designs that you could have is, let's say this is your robot, and you've decided to go with a full surround bumper. Now this is one of the more sturdy ways to build a bumper, is a full surround, but there are games where that's just not possible, right? You need an opening for the design that you have, and you are not able to make this. But a couple things to remember. One, even if you are to make this, I don't like that there's only 4 mounts in here, because this is only being held on by whatever's holding these 2 endpoints together. So I would like to see more connections. One thing that I see a lot is, let's say this is your robot and you've had to cut out this section of your bumper for your lifter, and you just left it like that. These little flaps that are created over here would not be supported or hooked to your frame in any way. And a bot coming along and hitting that or catching it will rip it right off, which will cause your bot to get disabled, and nobody wants that. So make sure that if you have ends that are out here that are hanging by themselves, that they have supports. And in this case, I would like to see all 4 bumpers attached to that frame. Now, one of the things to remember with the kind of the frame perimeter is that with some designs, especially like this one, if they didn't have this bar across the top, the wheels would be the only things there. That doesn't meet one of the next rules we're looking at. I'll show you that one. So a little bit more on this. Just make sure that you have a good way of fastening your fastener to the backer. Drilling a hole and threading wood and putting a bolt in, it's not going to hold. If you put a screw in that's intended to go into there, it's good, but make sure it's pretty stout, something that's actually going to hold it up. We find a lot of small screws, and they get sheared right off. One thing that works really well is if you go through here and you have, they're called hurricane nuts, but they're basically a nut that has these teeth on it, and when it's pulled in to the wood, it bites into that wood and it stays. That is a good way to make that mount, because that's not coming out. And then when you're hooking this part to your robot frame, there's a lot of different ways to do that. One of the ones that has become very popular, I'm not a big fan of, is the Andy Mark slide clip fasteners. You set your bumpers down, you have a little pin sticking up, and the slide goes on and holds to that pin. Almost every single one of those that I've seen has been damaged during gameplay. It's just not enough material holding the bot to the frame. It meets the requirement because it is very rugged, but you do not want your bumpers coming off during gameplay because they're going to disable you, and you don't want that. So, a couple things to remember with the corners. Open corners are not allowed. You have to close it in some way. You can wrap the noodle around. You can put an extra piece in this. You can get fancy and do a 45. This one, some teams aim for that, but don't achieve it exactly. So it still leaves it open. But this is one of the most popular. Extending the bumper noodle past the end of the backer to fill in that corner. This one and this one are probably the easiest and quickest ways to do that. All right, this is what I was talking about with the wheels and the backer. So if you have a 1/4 inch space back there or less, that gap can be quite large. If you have it deeper than a 1/4 inch, in this case, let's say 8 inches, then that distance can't be more than 8 inches unsupported. Now, one of the things that the chief robot inspector, well, there's two of them, Al and Chuck, one of the things that Al has said is making just a 3D print or a laser cut piece of acrylic sticking out, touching the bumper. He doesn't say that. He says that's not a secure way of doing it. So if you have something more substantial, I've seen some 3D print mounts that come out between the wheels that keep that belt from being entangled and actually are able to back that. That's a good way of doing it. Other ways of doing it are to do like this team did and have a bar go above the wheels and have your bumpers mount to that. That's not always possible depending on your wheel size and the distance from the ground. But if you have a backer that is in between those wheels, just make sure that it's stout, it's substantial, so that it has that backing ability. All right, we're done with bumpers. We'll talk about mechanical. So when we go to the mechanical section of the inspection, things that we're looking for is sharp edges. So you'll see us run our hand across your robot to make sure that nothing's going to hurt you while you load your robot in the field, field personnel that are out there, or the field itself. The other thing that Tim there behind the camera really loves is not damaging game pieces because he has to replace them. So these are things that we look for during inspection. There is prohibited materials. Make sure that you aren't putting anything on there. Most of the time, it's nothing crazy. Nobody's putting, nuclear waste on their robot and using it as ballast. But there are things that people are using that they don't realize are hazardous or prohibited materials. Lead weights that are uncoated are something that is a prohibited material. Any lead that you put on there for ballast or weight has to be coated or protected in some way. One of the other things that I warn you is that if you use something like shot or steel BBs or any of those type of things, even the lead BBs, put them in a container that will contain them. If it's raw lead BBs, which there are very few, but that you can still get those, and they're not coated, even a small little gap in those falling on the field can cause a problem. Lead is something that we don't want students to be exposed to. So for that reason, those are something. But that's one to look out for, is making sure that that is, if you're going to use lead ballast, that it is coated. Steel is a lot easier to work with because you don't have those rules. The other thing we look for is at the end of the match that you are able to remove that game piece without powering on your robot. If you guys have any decorations on your robot, make sure that there's something that's not going to conflict with another, like a game element, or mess up a vision tracking of another bot. So if you decided, for whatever reason, to put a whole bunch of April tags on your bot just for fun, that would be something that we would say you need to fix. Because obviously April tags are used, at least in this year, or past year I should say, for tracking. And so if you have them on your bot, it can mess it up. So just be mindful of that. All right. Electrical components, the main thing is that you need to not modify certain aspects of those components. I told the story in my last session, I'll tell you guys too. Had a student one year, he was a hobbyist, he did RC car racing. So he knew that if he took apart those brushed motors and put better brushes in it, it would work better. But that's a violation of the rules because he's modifying it in a way that could be unsafe. And in that year, the motor's casings were held on by bending the metal tabs over and holding the end on. So he had to unbend that, take the whole thing apart, change them out, put it back together, and then bend those back, which adds fatigue and a whole bunch of additional risk that we don't want you guys to have. So that's one of the reasons that rule is there. So be mindful of that. The next one is the battery. There's a large amount of battery choices out there now. Just make sure that it complies with the 17 to 18.2 amp hour rating. But the biggest one about that rule is right here. Securely fasten your battery into your robot. Last year there was so many robots that either got disabled because their bumpers came loose or disabled because their battery fell out. And that's not something we want for you guys to have to experience, is that lost match because something like a battery gave you trouble. Now, one thing to be mindful of is your battery should be secure. You want as little and possibly no movement of that battery in its mount. Because what happens is even your cables moving around just a little bit will eventually work that loose. And at ARL this year, we had one team that had a battery connector that completely melted all the coating that was coating it and melted the wire coating back about an inch because it was loose and it was making an intermittent connection with the battery. It got so hot that it melted all of that. But one of the things that's not to that extreme is if that is just getting knocked loose even a little bit, enough to let your radio or Rio drop out, it's going to take forever for a reboot. And you'll have that time where your bot's not running on the field. So one thing I recommend is every so often you check your batteries. I got a couple of batteries here. Check your batteries. Make sure that those terminal connections are tight. As you can see, this one is not. So that would be something that we'd take that tape off and tighten up. We're good here. Look for things on that battery that have been worn. In this case, the positive terminal of the battery is exposed. So when they put that in their bot, that's actually right against the back of their bumper. If it's the wood part of the bumper, that's fine. But if you have any kind of metal there, that being exposed could charge the entire outside of the robot with the same potential as that side of the battery. So do periodic checks. The other thing is when you get to the field, make sure that your battery is secure. You may have put the best strap in the world on there, but if you forgot to fasten it before the match, it does no good. So remember, have like a pre-flight checklist. Before you go on the field, these are the things that I need to make sure. I need to make sure that my vent valve is closed. I need to make sure that I have a fresh battery. That battery should be secure. Those are the kind of things that'll make it so that you don't miss that match. All right. Main breaker accessibility is another one that we have issues with. In case something goes wrong, and it has happened in the past, that's most rules that we have are either because something has happened and we want to prevent it, or we foresee something happen and we're trying to make sure it doesn't happen. But the reason that your main breaker has to be accessible is that if something goes wrong and your robot is not following a command, e-stop, let's say, we want to be able to disable that. Or let's say another robot makes contact with your robot and has shorted 2 of your internal wires inside your robot, and that's causing smoke, fire, anything like that. We want to be able to get in there and turn that robot off as quickly and as easily as possible. Burying your switch inside the robot sounds like a good idea to protect it from another robot, but there are other ways you can do that. You can make a case that goes around your main breaker so that the game pieces can't make contact, other robots can't make contact. I've seen some 3D prints that go around the red button so that you can get in there and push it, but a game piece can't, or another robot can't. This one is pretty accessible where it's at, but a couple of things to keep in mind. If you make it very accessible, but it's under a moving arm, that's not a good thing, because field personnel aren't going to want to try to jump in there and hit that e-stop with your arm coming up and down. So keep that in mind. In this case, this part of the robot doesn't run, so coming back here and hitting this e-stop is in a perfect location. It's also tucked in there a little bit so it's protected. One of the things that you can do to help with that is label it. Put a label on the side of your bot or on the top of your bot pointing towards that. And that'll help protect your robot. Because if something's going on that's shorting out in there, and that e-stop needs to be, or that breaker needs to be hit, that's also to protect your robot from further damage. So you want that accessible. Don't put it under a cover. If you put it under cover that has to be torn off before that, there's a situation where they may not be able to get that off, or may not have the time to get that off, and we don't want that. So make it accessible. Think about that when you're setting up all your electrical ahead of time, or put it into your main design so that you know where that's going to go ahead of time. A lot of teams will wait until they've built their bot and then start throwing electronics on it. So be mindful of that during the build process. All right, so the power distribution panel and the power distribution hub need to be visible for inspection. It no longer has to be visible all the time. So if it doesn't have to be there so that the field personnel can see it, but during inspection we want to. There are some teams that put their electronics on the bottom of their bot or hidden in behind a panel where it can't be seen without taking that panel off. That's okay as long as you're able to take it off for inspection, but I highly recommend that you don't put too many electronics on the bottom end of your robot. I had one team one year where they had a pretty tall side of their robot, but they mounted all the electronics on the bottom, but they did not mount a skid plate underneath there to protect it. The electronics were just open because they said there's no part of the field that's going under there. There's no bot that's going under there. But they had issues. They ran over a game piece, and it took one of the fans off one of their motor controllers. Now that's old time ago, a long time ago, when we had those type of motor controllers. But be mindful of that kind of stuff. You're going to have to cover it up, and there are going to be times that you have to replace something. You want that accessible. So try to build so that you can get to that stuff easy, but also remember that we have to be able to follow some of that stuff in the inspection process. I think I said secure the battery. There we go. So one of the things that we do have to track down quite often is the real power. So you guys notice there are a lot of connections on here. Does anybody know why it has to be connected to this connection? All right, so the reason it has to be connected to this, the Rio goes here, and the VRM goes here, is because these are buck boost protected. So we have all of these other connections on the power distribution module are just basically straight battery voltage. So if your battery dips because all of your motors kick on at the same time, it'll actually cause a reset on your radio or your Rio. So what these ports do is they have a buck boost converter in there. And what that does is if the voltage drops too low, it keeps it up. So these connections won't see that battery dip that these will. And it also keeps it at a regulated voltage for if the voltage goes high, which really is never a problem. But it's that battery droppage happens on almost every device or on every robot, and you want those devices not to see it because they will reset. So the Rio has to be connected to here, or if you have the Rev, it can be connected to any of these three, but not this one. Does anybody know why?
Because it's a relay port.
It's a relay port, and it's a physical relay. It's not, or a mechanical relay. It is not a solid state relay. So that one, it's switchable by your code, and two, if you hit this board hard enough or hit your robot with another robot hard enough, it'll physically move and cause that port to lose power. And if that happens, you would lose your radio, or in this case, the Rio. So you don't want that to happen, so make sure you connect it there. All right, so you've connected that together. Now you have to add your voltage module. So here it is. Here's your radio power hooked into those 12 volt 2 amp port. This is the only one that can be connected to. It needs that full 2 amps. If you connect it here, it may turn on and it may work, but at some point it won't. So it needs that full 2 amps. And then this 12 volt connection actually goes back to your power distribution panel. There are other ways to power your radio that are very popular. We have the cable that is splitting for the power injection here, which it'll go back to your voltage regulator module at those 12-volt 2-amp port, and the other one will connect that Ethernet to your reel. Or the newer, more popular one at this point is the new module. And this one, as you can see, is hooked to one of those 3 ports that's right there on the side. So it's protected the same way. And then you'll just hook it between your radio and your Rio. So either way you go, this one right here, if you want to look at it, does have this setup. One thing that is in this picture that I think is also worth pointing out is they show some ferrules on the end of that. If you don't know what a ferrule is, it's crimped onto the very end of your wire to keep it together, especially if it's stranded, right? It's going to try to spread out as it gets connection. Those can help quite a bit. They also, if they're done properly, will keep stray strands from shorting out some of your modules, so be mindful of that.
So question on that. I heard that it's recommended for the Weidmuller Stein, but not recommended for the Wago style.
Yeah, yeah, it's because of the contact edges. In the Wago, you have it coming together like this, and if the ferrule is turned on its edge, it makes very small contact, and it'll actually heat that up a lot. So those are things to be mindful of as well. With the newer ones, it's a little easier, and they show it in here, but yes. I think I just pointed out where the voltage module goes on here, connects to those. One thing to be mindful of is these 2 breakers that you have here, or fuses that you have here. When they ship, they're not always all the way in there. So make sure to push them down securely. You should see no exposure on the bottom. If you've replaced it, try to replace it with ones that don't have extremely long leads. Some of them do. And I've actually seen one of these get bent over at an angle. And these are just really cheap plastic, and they'll come apart inside, and that'll give you all kinds of trouble. On the newer one, again, just connect it to one of those 3 ports. All right. So CAN bus wiring is one of the other ones we have here. So if you know a lot about CAN, there's a lot of different ways that you can hook stuff up. If you don't know a lot about CAN, one of the things I recommend is that you connect kind of the minimal amount, and you follow that by doing a couple of things. Basically, one is this is going to have to be there. So one of the things that you can do is make this your start point for your CAN network. So this will come off there as your start. It'll go to, at very least, it's going to go to your power distribution and terminate it. Now, that only applies if you're using the PoE module. If you're using the orange cable, you have to have that voltage regulating module in there. So the CAN has to be, and that one is not connected, I'm sorry. But it has to be wired here. If you look right here, you can see that it says terminate. I know it's really hard to read, guys, but there's actually a terminating resistor. So the CAN network has to be terminated. And if you know a lot about the CAN network, there's other ways you can do that, and you can terminate it where you want to. If you don't, I recommend making this the last item in your CAN network and terminate it there. That way you have it set up, and that way it's connected to what needs to be connected. The reason that is required is because there's actually some sophisticated electronics in here that are actually monitoring what's going on in your electrical system and sending that data back to the Rio, and then to your dashboard, but also to the field. But that's something that can help you when you go to diagnose it. You also have that option on the new one to terminate. It's a little switch instead of a jumper, but make sure that if that is your terminating place, this is in the on position, and that your jumper is in on the other connector. All right, so most of these rules I'm not going to go a whole lot into, but be mindful that if it's a 40 amp breaker, it has to have 12 gauge, 30 amp, 14 gauge, 20 amp, 18 gauge, and that you have to follow wiring color code. that rule is applied to any wires that you add. You don't have as much anymore, but you used to have some of the motors that had two of the same color that were from the manufacturer coming off of them, and that's allowed because it's on the it's on the downside of your motor controllers. Those motor controllers can reverse and go forward, so that part doesn't matter as much. But on everything else that you put in and everything that you put in, it should be color-coded, and it should be the right gauge for what it is and what you have in there as a breaker. Be mindful, it says copper wire only. The reason is wire can get expensive, especially we saw that during the COVID times and stuff. The wire got very expensive. So you'll find wire that's cheaper, but it's not necessarily copper wire. One of the things that has hit the market very widely is CCA, which is copper-coated aluminum. That wire cannot carry the same amount of current without melting. It looks the same because it's coated with copper, but be mindful, especially if you're buying your wire off something like Amazon. Be very mindful that you are getting copper wire and not CCA. All right, one connector per Wago connector. You can't put two wires into there. If you need to make a junction, you come off of that connector and you make that outside of there. Just make sure it's well insulated. Let's see. Frame isolation, make sure that there's nothing. We're going to check that during inspection. Make sure that you don't have any of your components grounding to your chassis or any of them even tied to the hot. The chassis needs to be isolated from any of your electronic components. 1 year, in the kit, they had this camera. It was called the Axis camera, and the back of it was grounded. So if you hooked it directly to your frame, it caused a problem, and everybody was trying to figure out where it was. And finally, somebody posted on Chief Delphi that, hey, this is a thing, and then first, told everybody to isolate it. But that was often a problem we ran into because the teams didn't see that. So next is pneumatics. I like pneumatics. I think they have a lot of things, but I see teams challenged by them a lot. So a couple things to be mindful of. Again, we have a no modification, and that's really a safety thing. If you start modifying like the pistons, they can explode and hurt you, and we don't want that. So let's take a look at a pneumatic system in its basically minimalistic form. You're going to have the compressor and hard lined with a solid fitting here is your pressure relief valve. I'm going to talk a little bit more about those as we get down to another slide. Next, we have your storage. This is where you're going to have your high pressure storage for just keeping that air while you're not using it and pressurizing those tanks from the compressor. You have your pressure switch here. This is what tells your Robo-Rio to actually turn off the compressor when the pressure gets there. You have your storage gauge. This is what tells the pressure of your high pressure side of your system. A vent plug. We have a relieving regulator. This does two things. One, it drops the pressure on the downstream side of it to your working pressure, which shouldn't be more than 60 psi. But it also means, the relieving part of it means that if something happens here, let's say you have pistons and you have your arm fully extended and you slam into the wall, that pressure in those cylinders will go up, which can take that pressure above the 60 psi for that working pressure. And what the relieving regulator does is it blows off that extra pressure, keeping that side safe. We have a gauge that indicates the working pressure so that we can see those both. And we'll be checking those. You'll see in my next slide that we have a wide selection of different gauges you can get. These are becoming extremely popular, the really small ones, but they are very hard to read. One of the things you notice here is we have a 0, a 50, and a 100. The numbers that we care about in inspection is 120 and 125. It's a little hard to find that on here. It's not impossible, but it is really hard. These bigger gauges do allow us to see that easier, but we're seeing more and more of these. One of the ones that's really hard is if you look at this robot, you can take a look now, or you can when you're going out. One on there only has 2 markings. One is a 5 and one is a 10. And then those are actually moved way down on the body of here, and you don't know which check mark they go to. So be mindful of that when you're choosing those. One thing that I have started to recommend to a lot of the teams is going away from the settable blow-off and going to the fixed blow-off. A lot of teams struggle with setting these because they have to be set by adjusting them and then tightening the locking nut while not moving the top. And so it takes 2 wrenches at the same time. And most of the time what I've seen is teams that have that way wrong is because they used this to tighten this fitting in. And now it's completely off because there's a spring in there with a little ball. And the tighter that spring is, the more pressure it takes to pop that open. And so the other thing is if you take this all the way off, you open the sight up too far, that spring and ball go flying like 30 pits away and you'll never see them again. There's a drawback though to these. Although these are set and are at a fixed pressure all the time, they are at a fixed pressure. And in industry, there's tolerances. Okay, that needs to blow off at 125 psi. Well, if it went to 130, that wouldn't be bad. But in robotics, we do care about that. It has to blow off before 125 psi. Now, they are quite loud when they blow off. They usually startle the person the first time they hear them because it relieves that pressure really quickly and then closes. The other drawback is occasionally these are set, supposed to be at 125, they're at 120. That's fine for us at inspection, but that may cause problems. The pressure switches also have a similar problem. They're supposed to be turning off your compressor at exactly 120 psi. If they are set at the factory, you cannot change them. Very, very often, they are not set right at 120. They're turning off at 115, or they're turning off at 125. Now, 115 at inspection, we're okay with that. You could be okay with that. But if you're trying to store the most amount of pressure you can in your tank so you have that volume to use, that may not work for your strategy or for your build. So be mindful of that. All right, so on the pneumatic control module, you'll see that the pressure switch gets connected here and the compressor gets connected here. And that's what's going to control your on and off of that. If you use pneumatics, the pneumatics control module has to be hooked into your CAN network. That's how it communicates back to the C-REO, so make sure you put that in there. Now, if you're either got these parts or you're a newer team, this is kind of the newer setup. So here's the pneumatic hub for that, and here is the new pressure switch. This is an analog pressure switch. The other one was digital, so it's on or off, right? It'll tell you either you're at pressure or you're not at pressure. This one can actually feed back data to your drive station that tells you what the pressure of your system is. And if you do that, it'll hook to this analog section of the pressure sensors on here. And with this setup, you can still use the old one. You just hook it to the digital side. And as I pointed out on the other one, it has to be connected to your CAN network. All right. So the last thing that we do during inspection is a power on check. And the things that we're looking for during the power on check is the first thing is we're looking for unauthorized communication. Some of the things that you may not realize that need to be off in your driver's station when you go to the field, your Bluetooth needs to be off and your Wi-Fi needs to be off. You're hardlined at the field to communicate to that radio that's then going out to your robot. But those wireless devices need to be off for that. Keep that in mind, especially if you have a controller, which is great because it's wireless. It won't work. It has to be a hard line to your driver's station. You can't use wireless controllers unless they can be tethered, and that tether disables its wireless functionality while connected. We'll check the pneumatics. We'll check that the compressor stopped at 120 psi or less. We'll see that the main pressure is less than 120 psi, that the relieving valve. That's that one that I told you is the relieves just in case the pressure goes too high. But that actually pops open when it's supposed to. And to do that, we'll either jumper the pressure switch if it's digital, or we'll use one of the buttons to do the same thing on the new analog ones. We want to see that your signal light is visible on the field so that we can see whether your robot's powered. And if you didn't know, your robot signal light tells you whether your bot is enabled or disabled. And so that is a huge thing. We're going to check to make sure that your driver station has your team number on it, that the software version for both your Rio and your driver station are up to date and to the minimum standards to compete. And the reason some of these updates come out, especially if it's after a week of competition, is because they found something that they wanted to update and they forced that update. So those weekly updates that you guys can get, that'll be mentioned in there. All right, and then when you turn off the power with the main breaker, that everything on your bot goes dead. And then the last one is your operating console is within specs. Just make sure that when you build a console, if you're taking more than just your controllers and your computer up there, that it fits within those. All right, any questions? Yes?
How long average does it take to inspect each?
All right, so one of the last teams that was in here last session, they told me their inspection was finished in 13 minutes. It's a little fast. Average inspections are 30 to 45 minutes. One of the main factors that extends that time is pneumatics. If you have pneumatics, it takes a little bit longer. But one of the other ones, if we cannot trace the wires going from your Robo Rio to your power distribution model, or we can't trace it from the radio back to where it's supposed to go, then that takes us additional time. Some of the things that you can do to speed that up, label your wires. Label them where they're going, especially if you use something like a cable management like wire loom, or something where you're tucking those wires into some sort of cable management where it can't be seen. Label the ends of the wires. It'll make it easier for you. It'll make it a heck of a lot faster for us. The other thing you can do to speed that up is make it so that we can actually see that stuff. If we can see where those wires go, and where your Rio is, where your power distribution module is, and where those wire ends are, it makes it a lot faster. So if you throw some tags on there to tell us this is this side, this is this side, it'll go a lot faster. Any other questions? Or did that answer that question? Okay. Anything else, guys? No? Well, thank you guys for showing up. I wasn't expecting too many people to actually come to this because inspection is a part of going through the process, and most people are like, yeah, I'll go through that later. But thanks for coming, and again, remember the inspectors are there to help you. We want you to be able to get through inspection. We want you to get to your matches, and we are going to do everything we can to make that happen. I know sometimes it'll feel like the inspector's telling me I can't go out. He's making me do stuff I don't want to do, but we're doing it for a reason. We're there to try to keep you safe. We're there to try to keep the game fair. So keep that in mind. If you guys have any problems during a match, come let your LRI know. I'll be the LRI at one of them. Damon will be at the LRI for the other one. So just come let us know if you have any issues. So thanks, guys.